Warahmatullahi wabarakatuh, and have a nice day to everyone. To this session we will going to discuss the answer for the question test 1 for the set 1. We'll only focus on the AC part. Alright, from the figure given, figure 0.1, they said the VCC equal to 10 volt, RE equal to 0.8, RC 4 kilo ohms, R1 56 kilo ohm, R2 12.2 kilo ohm, beta 10, and VBE 0.7, and last but not least VTE is 0.026. Alright, for the first questions, the question asks us to find the IB, IC, and IE. So all those terms are in the DC analysis, so we need to apply AC analysis to find the IB, IC, and IE. So before that, we need to implement the DC rule. The DC rule said the capacitor will be open circuit, and the AC source here, as the voltage here, become short circuit. Alright, so after we open the circuit, this part will be drop out, and this part also will be drop out when the capacitor C2 also open. Alright, so we redraw back our circuit. It become here. We have VCC, RC, RE, transistor. We have R1 and R2. In this situation, we very hard to find the IB, because which loop that we want to do the KVL. So to make a simpler way, we need to convert this circuit into the normal circuit. So we also have, if we redraw, we have VCC, RC, RE, and the base side we have a resistance. We call resistance is RTH, and the voltage we call VTH. The VTH is a voltage drop at the R2, means that the voltage at the VTH will entering the transistor, so we call it VTH. And then resistance that entering the transistor here, we call VRTH. The RTH is a resistance located up parallel between R1 and R2. So let's recalculate. The formula to calculate RTH is R1 parallel R2, means that R2 times R1 and R over or divide R2 plus R1. Then we compute, then we get the RTH equal to 10 kilo ohms, and then the VTH, let I say that voltage, the voltage drop the R2 with the voltage drop at R2 we entering the transistor. So VTH equal to R2, because the voltage it drop at R2 over R1 plus R2 times VCC. Then you replace the value, then we got the VTH equal to 1.79 volt for the VTH. So we entering the value inside our circuit in the normal circuit. So VCC equal to 10 volt, RC equal to 4K, RE 0.8K. We have RTH 10 kilo ohms and VTH 1.79, and we have also VBE 0.7. So now we can, from this circuit, then we can easily find out the value IB by implement of first loop. So the first loop said the error will meet the source minus source first, so minus VTH plus RB RTH plus here, and meet a positive first, so plus VBE, and then plus we met here, so plus IE RE equal to 0. Right, So we rearrange back. RTH bring to the right side, become VTH equal to IB RTH plus VBE plus IE RE. So since they have two unknowns value, so we need to replace IE here, become IB. So IE equal to 1 plus beta IB. So we replace this IE into the IB terms. Then we got the new set equations. Then next step is you combine the IB in the one side at the left side and the voltage at the right side, and then make a simplifications. IB equal to RTH plus 1 plus beta RE equal to VT tolak minus VBE. So to find the IB, you bring all the resistance to the right sides. So since the resistance the right side is products or times, we bring the left side become the divisions. So VTH minus VBE over RTH plus 1 plus beta RE. Then those of term we know the values, and we replace the value and we compute, and now we got the IB become 12 microampere. Usually IB in the micro value. So once we got the IB, we can find the IC by implement beta IB. So by time of 100, we got the IC or ICQ equal to 1.2 milliampere, and we can find the IA by apply beta plus 1 IB, or you can use IE equal to IC plus IB. So you got the same value is 1.212 milliampere. So we finish for the first questions. Now we go to the second questions. The second question asks us to find the VCE, VC, then VE. So to find the VCE, we need to run the second loop. So the second loop said the current flow at the anti-clockwise, because our error of transistors go out, so we need to follow the direction of our transistor. So from this loop, we made the VCC first at the minus signs. So we got the minus VCC plus we made the ICRC. The second we can see VCE here. So we made the positive signs VCE first, then we made the IERE equal to 0. So we rearrange our equation, it become VCC, bring to the right side, VCC equal to ICRC plus VCE plus IERE. Since all the value we already know, so we can simply find the VCE. So all the ICRC turn to the right side, so become ICRC minus IERE. Okay, so it become like this. Then you replace the value, then you can get the VC equal to 4.23 volt. Now after that, you can find the VC. The VC is a voltage remaining after VCC minus ICRC. Means that the value from VC from here until here, because the VC. So the voltage remaining is 10 of VCC minus ICRC. So we got the value for VC 5.2. Then for the VA is simply IERE, you got 0.97. To make sure VC is correct, you must compare VC with the VCE. VC much larger than VCE, because VCE equal to VC minus VE. So this, if you minus both of them, you can get value for VCE. Right. The third question asks us to draw the small signal equivalence. So once you say the small signal equivalent is represent as AC analysis. So in AC analysis said, a capacitor, we need to short its current, and this DC source we going to get ground. So our source VCC we ground, a capacitor will be short, capacitor will be short. Right? Okay. Once a capacitor short here, the current will flow to the new shortcut way or easy way, and then current not flow through the load. Instead of using the load way, the current will use the shortcut way that have no load. So we can eliminate RE here. So first of all, to apply the small signal, you draw from the transistor itself. So you have 3 points. We have a base B, E, and C. At the base, you have the transistor of R pi, and the voltage drop the R pi we call the V pi. And then our emitter we connect to the ground, directly to ground, so no RE here. And then at the collector we have a diamond, the current here, so the current is GM V pi. Right? Okay, from the base leg you connected with the R2, and at the same place you connect the R1, go to the ground. So okay, R2 and R1, and then you connected with the series with the resource. So to make more easier, you parallel R1 and R2 because they are parallel. So after that you can make a more simpler circuit where the R1 and R2 are parallel. Okay, then we settle on the base side, and also settle at the emitter side because there are no resistance. And then we try to find out the value of at the collector. The collector connected to the RC. The RC will be going to ground, and then at the end of RC we can find the V out. So everything you need to label it correctly. For the fourth question, the question asks us to find the gain. So this question asks us to find the value of AV. Right? Before that, we need to find the R pi and GM. So the GM formula is ICQ over VT. So IC that we are calculate at the previous questions, we got 1.2 milliamp. So we divide by VT 0.026 volt, and we get value for GM 46.15 milliampere, because the ampere over volt. Right? For the R pi, formula for R pi is beta VT over ICQ. So beta is 100, Vt 0.026 over to 1.2 milliampere. Then we got the value R pi 1.67 kilo ohms. Right. Okay, now we can proceed to find the AV. AV equal to V out over Vs. So what the formula for V out? We can see on the circuit V out. V out here, the voltage drop at the RC. So we need to force our current entering from the top. So means that inverse from the GM. GM V pi is the current. So we try to inverse it to entering from the top. So it become minus and time with RC. So we got value for V out. Now what value for the V in, Vs? What the relation between Vs and V pi? V pi are parallel with the Vs. They are parallel. So means that the voltage parallel are equal. Means that Vs equal to V pi. Right. So after that we can apply for the AV formula. So V out over Vs. So we got V out and we got Vs. So we divide V out over Vs. So Vs equal to pi. So GM V pi RS, GM V pi RC divided by V pi. So we can eliminate V pi itself, both of them. So the remaining formula for AV is AV equal to minus GM RC. Okay, by replacing the value, you got the value for the AV become minus 184.6. There's no unit here for the AV. Right? That's okay. That's all. That's all for the test 1 question 1. If you have a question regarding this discussion, you can ask me or PM direct me. Right. Thank you guys.